So guys, this is our STM32 Nucleo board, H753ZI based. So I press this button, this is the user button, this blue button. As soon as I press it, see all three LEDs turn on over there. I release it, LEDs turn off. If I press it, the LEDs turn on. See, if I press and release, only then the LEDs turn on. See, once it's pressed, LEDs on, else off. So guys, welcome to learning microcontrollers. In this video, I'm gonna show you how we can use a Nucleo STM32H753ZI 144 pin STM32 board, and then we will use the onboard push button, user push button, that is the blue button, to turn these LEDs on off. So let's get started. So guys, these are the three LEDs on board that we will turn on and off based upon this button. So whenever this user push button is pressed, the LEDs will turn on. Once it's released, the LEDs will turn off. So that is what we are going to do in this video. So let me introduce you to the hardware, then we move on to the programming. So guys, this over here is the hardware. As you can see, that's my Nucleo board. This is the push button we will use, and these are the three LEDs over here that we also used in the previous lecture. See, so let's get to the programming. So guys, let's open the STM32 Cube IDE. There it is opening up. Wait. Okay guys, there you first of all select the workspace. Workspace is just like a main folder, and then later on we will make our project files. Then whatever the project file you make will be stored in the main folder. So this will be the main folder, and the project files will be inside this subfolders. So this is the beauty, that it automatically organizes your files. So click on launch. So the workspace will be launched, whatever you selected. Just wait. Okay, here you go, it opened up. I maximize, zoom in, go to the left, click on file, new, STM32 project, wait. Guys, remember you have to be connected to the internet while using this IDE. So it's better that you are connected. It will update, and it will also allow you to select a microcontroller. Or you may select a microcontroller first, and then after that you may get disconnected from the internet. It will be fine. Now guys, go to the left. Either you can go with the microcontroller selector, or you can go with the board selector. I will go with the board selector because I have it on a board. So I write here Nucleo H753ZI. Here you go. Now this thing, you go. If you are not connected to the internet, this will not appear. So you have to be connected to the internet for selecting the board or the microcontroller. Now verify that this is the product. Yes, this is indeed the board I have. Also you have some description, you can verify it from there. So that's all you need. And you also have the option of fetching its data sheet and other resources, large picture, or even buy it from here. So that's a great help. So click on next and write the name of the project, button, interface, STM32 tutorial by learning microcontroller. So that's the name I wrote. You may write any name you prefer. Just click on finish. Now the GUI will be initialized. You have to wait until your GUI is being initialized. Wait. Okay, it is asking for some onboard components. Do you want to like keep them? Because we have selected a board, not a microcontroller. So we have LD1, LD2, LD3 LEDs. Then this is the user button. So we will program user button in such a way that these LEDs will turn on as soon as the button is pressed, and once the button is released, they will be off. So we need all four components. And also this is asking for a virtual COM port, like you have in the Arduino type serial terminal option on board, like they have a small chip. So yes, I will keep it. I don't have no problem with that. And then after that, click on OK. Another thing that you also have on board is that you also have a onboard ST-Link as well. While if you go with just a microcontroller, then you have to buy an ST-Link separately for programming. So guys, these are the settings. So let's wait for the GUI to be initialized. Now it is initializing the GUI. It may take like 20 to 30 seconds. You can watch over here. It is doing its job. It sometimes takes 30 seconds, sometimes 40, sometimes 50. Just wait, it is doing its job. You can see on the right bottom. Wait. It is downloading something, so it is updating itself. Wait. Okay, here you go, it has started rendering. So it will keep on updating itself. That's why you need to be connected to the internet. Okay, there you go, the GUI has been initialized. Okay, still wait. Once it's removed, only then you will be able to use it. Okay, there we go. Let's zoom in. So at the bottom you have this PB0, that is your first LED, LD1. You have to right click on it, pin unlocking, then click on it and make it a GPIO output pin, because LED is always connected to an output pin. Okay, now go for the second LED. Second LED is here, this one, PE1. Just make it a GPIO output. It's already GPIO output, that's all you need. Now go for the third LED, that is over here, that is this one, LD3. Right click on pin unlocking, then click and make it a GPIO output. That's all you need. So now go to the left for the button. You have the button here at PC13. So this is your button at PC13. You click, right click, pin unlocking, then the button must be an input. Make it a GPIO input like this. So all four things are initialized. Then go to the right, left. Here you have the project. Click on project, click on generate code. Here you go, click on yes. Okay, the code is being generated. Now half of the work has been done already by the GUI. So that is the beauty of STM32Cube IDE. So this is your main header file. Now here go down, here the one-time loop starts, hash include main void. Now inside it you can see it has automatically initialized the whole libraries. You don't have to do it. Clock is initialized, GPIO pins are initialized, and now all the three LEDs have been initialized automatically. Then the button is also initialized. See, it has already initialized the button, the push button. Then this is like in case of Arduino you have a serial monitor. This have an onboard chip on the board which allows you to use it like you have a serial monitor in the STM32. So this is also automatically initialized, and then from here inside it, this is your forever loop. Inside this while you will write your code whatever you want. So for the code, just let's get to the chat GPT. We will generate the commands from the chat GPT. So we take help from the AI, because if it's available then we should make use of it. Okay, there we go. It opened up. I click on introduction to ChatGPT. Then I click on try ChatGPT. There you go. Now the important thing is how you write the prompt. I tell you how to write the prompt. So you have to learn how to write the prompt. Okay, first of all, tell him that I have Nucleo STM32H753ZI board. I am using STM32 Cube IDE. Then you tell him I have three LEDs connected to pin PB0, PE1 and PB14 as LED1, LED2 and LED3 respectively. Okay, then you tell him I also have a button connected to pin PC13. I want you to generate me a code whenever the button is pressed for 100 milliseconds. This is the debouncing delay, is being pressed for 100 milliseconds. Then all three LEDs turn on, and as soon as I release the button, all three LEDs turn off. I click on upload. Now it will generate the code. I have to wait. Just wait. Okay, verify this. Okay, that's correct. Okay, it's fine. It is generating the code. Okay. Okay, we already have these initialized. We have this initialized. Go down. Okay, it is generating a very complex code with interlocking. So I tell him to write me a code by using button read, LED write, and delay commands. So I'm just limiting, and also use if else. Now he will write me a simple code because this seems to be a very complex version. So I just want you to go through a simple code. Okay. Okay, he's also giving like these, he have declared headers. I don't want these headers as well. So I tell him to remove pin variables PVs. I want actual pin names. Okay, just tell him whatever the type of code you like. I just like it simple here. Okay. Okay, now that's what I want. Okay, now that will be a simpler and the most easiest version for us to understand. Okay, just we need to copy this part, the part in the while one, because rest is automatically generated till here. Okay, that's all we need. Now go back to your cube ID. There it is. Now go in the while one, here you paste your code. There you go. Okay, this is our code. Okay, I made a mistake. You have to write your code here above the end while. Okay, like this. Okay, this is fine. Okay, now here, as you can see, let me explain this to you how it's working. So guys, this is the command. You may, like, we didn't went through the data sheets or documents, we just got it from the chat GPT. Okay, this is the command, hall GPIO read pin. Now this is the syntax of the command. Understand, GPIO, first of all you write the port, then you write the GPIO pin, that is the pin number 13 where our button is connected. So reset, this means that I myself do not know on the board like what it's done. Like if the button is pressed, a 1 is sent or a 0 is sent. I don't know this. Either I can use a DMM or just go with whatever the option is. So in our case, if the button is 0, we consider it to be pressed. Like here, he is taking that if the PC13 pin is 0, it means the button is pressed. Then this is a debouncing delay, halt delay. This is a syntax to give the delay. Then if it's still 0 for 100 millisecond, only then it is considered to be pressed, and he again checks the button. If the button is still pressed, only then it is considered it is pressed. And after that, if the button is pressed, turn on all three LEDs. Now this is the command to turn on the LEDs, hall GPIO write pin. Now this is the command. Now GPIO, this is the part of the syntax. There you write your port name, that is B, and pin number, that is 0, that is the LED 1. It will be turned on. Then for the second LED, and do for same for the third LED, and your 3 LEDs will be on. Then close both the loops and then go for the else. Now again, hall GPIO write pin. Instead of using set, GPIO pin set means 1, and GPIO pin set means reset means 0. Set means 1, reset means 0. That's how the hall library works. So this is how you wrote this code. Now let's build this code and see what happens. Click on this run button and it will build the code. But before that, let me connect my STM32 to the computer because it's not connected. Okay, I'm connecting it. Okay, it's connected. Here you go, it's connected. Okay, click on this run button, this one. This will build the code. Okay, building project, you have to wait. You can also do it from here. Wait. Okay, here you go. It's click on OK. Wait. Okay. it will do the checks. Okay, 0 error, 0 warning, that's fine. Now we can burn it into the microcontroller. Again, click on the run button. Now it is burning it into your board. Like now here you don't have to connect an ST-Link, just connect the micro USB cable. That's all you need, because this have an onboard ST-Link. Here you go, the code has been downloaded and verified successfully. So let's get to the hardware. Okay, let me zoom out and show you the hardware. So guys, here you can see the LEDs are on by default. This means that we have gone the opposite way. I press a button, they turn off. See, this means that whenever the button is pressed, a 1 is sent. So see, it is working, our code is working, but it is inverted. Now to correct this, because I didn't know what the button sends, I go back, let me zoom in, I open the magnifier. Now here it says set, you make it reset. Now if the button is 1, only then it is considered to be set, okay, else it will be considered off. See, if the button is pressed, this means the button is 1, only then it is considered to be pressed. So in the previous case, we thought that the button is gonna send a 0 whenever it is pressed. So I click on build, update the code, click OK. You have to wait, no errors. Again, you have to do the same. It verified the code. Now it will burn it. It is waiting for debugger. Just wait, the code is being burned. Wait. Okay, it's verified and shutting down. Just go to the hardware now. Now see, the LEDs are off by default. I press this button, LEDs turn on. See, LED is off. Once the button is pressed, they turn on. As soon as I release the button, they turn off. See, now it is working perfectly fine as it should work. See, now see, this is indeed a very beautiful way of doing programming and learning about the microcontrollers. So in the future lectures, we will go into more advanced features of this, like going for the UART port, enabling the SPI, using I2C modules, etc. So keep on following this course. So we'll see you in the next lecture. Goodbye until then. So if you have any questions, you may ask, and I hope you guys learned something from this video. So have a nice day.